6.3. We'll be solving systems of inequalities. Systems of inequalities. Okay, I want to graph these two. So I want to make a sketch out of those. And then I want to put my solution here on the second graph. Now, to graph this, I'm going to remove all the parameters. Here, I have a plus 2. That means that my parameter C is 2. So I'm going to remove that. So this will be y equals natural log of x. Okay, y equals natural log of x, as we recall, has a vertical asymptote of x equals 0, an x-intercept of 1, 0, and it has a rapid to slow growth. When you put the parameter c on here, we get y equals natural log of x plus 2. The c parameter of plus 2 will move everything to the right, sorry, to the left 2 times. So now the graph has an asymptote that moves over twice to the left, which is now x equals -2. The point 1, 0 moves over to the right 2 times, so it becomes -1, 0. And the graph's behavior is still rapid to slow increase. Okay, so let's draw that. X equals -2. Now, let's graph this one right here. Let's get another pen. This will be this parameter right here, this negative, that's an A parameter, which is 1. And this is a C parameter, which is 2. We're going to remove all the parameters, and we get natural log of x. The natural log of x has a vertical asymptote of x equals 0, a point of 1, 0, and rapid to slow increase. Then we're going to put our C parameter onto this, which is y equals natural log of x plus 2, which will give us, will move the graph back twice. So our vertical asymptote will go back to x equals -2. The point will go back to x equals -1, 0. And the graph's orientation will still be rapid to slow increase. Okay. Next, we're going to put our A parameter on here, which is negative natural log of x plus 2. And the negative A parameter is going to give us a reflection about the x-axis. So with that reflection, the vertical asymptote will remain the same, x equals -2. The point will remain the same, which is -1, 0, but it will have a rapid to slow decay. So let's draw that, rapid to slow decay. Now, the last thing we want to look at is we want to find a point that's off these lines that we can test. This point 0, 0 is off both lines, so I can use that as a test point. So let's put in 0, 0 as a test point into this one, and we'll get 0 less than or equal to the natural log of 0 plus 2. And I know the domain of a natural log function. When you put anything in, it's going to be a positive answer. So 0, so this positive answer will be bigger than 0. So this is true. So I'm going to shade toward the point 0, 0 for this line right here. So this will be right there. All that shading. Okay, next, a test point for this one, we'll still use 0, 0, and put 0 here for y, and negative natural log of 0 plus 2. and so we'll end up with negative natural log of 2. Again, we know that the natural log of any number, or should I say natural log of a number within this domain, is going to be positive. So this is going to be a positive times a negative, which will be negative. And a negative number will be less than 0. So this is true. So I'm going to graph toward the point for this line right here, for this graph right here. And where the lines intersect will be the solution of the system. So the solution of the system is actually this portion right here. This is the solution of this system. All points that lie within here and everything along the edge of the two curves. Okay, number 4. Number 4, we want to graph this, so I want to make a sketch graph, and then the actual solution of the system graph will be there. All right, this negative 2 is a D parameter, so we have D is negative 2. And this negative right here, that's a B parameter, so B is negative 1, and the negative 2 here, that's a D parameter. So I want to strip off my parameters, and we end up with y equals e to the x. Y to the e to the x has a horizontal asymptote of y equals 0 and a y-intercept of 0, 1. And the behavior of the graph is slow to rapid growth. Next, when we put the D parameter on here, it will fall twice. So what happens to the horizontal asymptote? It goes down to y equals negative 2. What happens to the y-intercept? It goes down to 0 and negative 1. The behavior of the graph is still slow to rapid growth. Okay, so we have slow to rapid growth. And again, this is going to be solid because there's an equal sign there. Next, I'm going to take off both parameters, the B parameter and the D parameter, and we'll have y equals e to the x. Well, we'll just use this y to e to x here. Next, we'll put on the parameter, the B parameter, which is e to the negative x. And e to the negative x gives us a rotation about the y-axis. So, the horizontal asymptote remains y equals 0. The point 1, 0, 1 remains 0, 1, but the orientation changes from rapid to slow decay. And next we'll put on the D parameter, which is y equals e to the negative x minus 2. And this will lower the graph twice, making the horizontal asymptote y equals negative 2. The y-intercept now becomes 0, negative 1. Let's put that on the other side. 0, negative 1. And the behavior of the graph, I should have left it over there. And the behavior of the graph is still rapid to slow decay. Okay, so we can draw this rapid to slow decay. Alright. Alright, now I need to choose a point that's not on the line, either line. And let's choose this point right here, 0, 0, as a test point. So test point 0, 0. If I put into the original, I get 0 greater than or equal to e to the 0 minus 2. E to the 0 is 1 minus 2, which is negative 1. Now, 0 is greater than negative 1, so this is true. So, for this graph right here, we're going to shade everything above with the 0, 0. Now for this side right here, we're going to use a test point 0, 0. And so we'll end up with 0 greater than or equal to e to the 0 minus 2. This ends up being 1 minus 2, and 0. Is 0 greater than 1? Greater than or equal to 1? Yes. So this is true. So that shade will be above here with the 0, 0. So the solution of the system will be everything within this area right here. So the solution of the system will be within this area and the edge of the two graphs.